All righty, good afternoon, lads and ladies. Welcome to our very first Calc 1 meeting of the semester. You probably just got a little notification that we are recording this meeting. That is the case, and I will be saving and uploading this video to YouTube afterwards. My YouTube channel is fully open. Everybody can see it, so just a little heads up. Be mindful of what's going on in your feed. Today, we are going to talk through the syllabus, of course, day one stuff, but then we are going to get into some mathematics. So you want to have your notebook and pencil handy. You won't need anything else today, but you want those things. Let's class fills up. Very good. Okay. The other thing I'll ask, I know, again, I did just say, be mindful of what's going on, and these will be posted to YouTube. But if you could, I would appreciate it if you could leave your video feed on so I can get to know you a little bit, know your face and who you are. That's always a nice thing at the start. So I'm going to ask you guys to turn your feeds on. We'll give just a few seconds for folks to trickle in. I'm getting a call from my office, and then we'll get started. All right, and they hung up. So here we go. I am going to do a few things, get us introduced to the way the class runs. So this is the document for our class. You can think of this as being like the blackboard or whiteboard. Everything that I put here, you will want to put in your notes. That's kind of, I'll do my best not to write anything here you don't need, and I will always write what you do need. So please do your best to transcribe the notes as they come across. If you need me to pause, I'm going too fast, anything like that, don't be shy about asking. If I'm going too fast for you, probably I'm going too fast for everybody, and everybody else is just too shy to say something. So please speak up. I will always begin with a little title card. So this is MAC 2311. The section number is 004. We want to remember that. That, of course, is Calc 1. And today is the 5th of January, 2022. I did it right that time. I've been writing 21 every day. It's always frustrating. The other thing I'll always do as a part of our little title card is tell you what we're up to today. So today we're going to go over the syllabus, talk a little bit about WebAssign in case anybody's new to that. And then we are going to begin on some mathematics. We're going to talk about tangents, tangent lines, and velocities. And we're also going to introduce the concept of a limit. All right, so this meeting is an hour and 15 minutes long. We'll be getting out at 3:15. And really, this bit is just going to be a qualitative discussion to kind of try to give you an idea where we're going. But then limits, that is actually a section we're covering from the textbook, which is section 2.1. Now, before we get into the math, we're going to spend a little bit of time doing the normal first day stuff. I know it's not fun. I'll try to make it as quick and painless as possible. Zeroth things zeroth. This is the Canvas course. Obviously, you all found this because you are here. My name is John Filesticker. You can call me Professor P or John, honestly, whatever you want. Call me whatever you want. If you want to bravely try to pronounce this weird last name, it's a file sticker, like a sticker you put on a filing cabinet, but don't worry about it if you don't want to. Whatever you want to call me is fine. I have a master's in math that I got at UF after spending a few years there researching analytic number theory, specifically like additive number theory, Dirichlet series, combinatorics of Farrer's graphs, stuff like that. I did my undergrad at UF, but I transferred there after going to community college down in Sarasota. This is a Calc 1 class, so we're going to be talking about calculus. We're going to meet Monday, Wednesday, and Friday from 2 to 3:15. The Monday meeting is officially a lab meeting, but because this is a hybrid, synchronous, like online type thing, we're not meeting in a different place. We're not doing anything like that. So just think of it as a class that meets Monday, Wednesday, and Friday. And sometimes on Monday, I'll ask you to do some other stuff on Desmos. Really nothing terribly special about the Monday meetings, except occasionally I'll ask you to do a separate little project. Office hours for this class are primarily Monday, Wednesday, Friday, 1 to 2 p.m., just before, and Tuesday, Thursday, 11 to 12 p.m. Those are both in Zoom, and if you want to join one of those office hours, you just click the links here in Canvas. It'll load you into a Zoom meeting the same way you all got here today. If you want to meet outside of those times, I can meet on Zoom for an office hour outside of those times. Just send me a Canvas message. We can arrange it that way. Or if you want to meet in person, I am teaching one in-person class on campus Monday, Wednesday, Friday from like 9 to 10:45. And I'm available before that, not after that, because I have to rush home for an online class. The final exam for this class is Tuesday, Tuesday 4/26, and I would strongly advise you to put this in your phone's calendar right now. So our class meets Monday, Wednesday, Friday, has a Tuesday final. That's a little bit weird. It's very easy to get caught up at the end of the semester and forget that that's going to happen. It's also not at our normal time. So it's a different day and it's a different time. So whatever you use to keep your schedule, if you use a paper planner, if you use the calendar app in your phone, something else, go ahead and put that in there right now. Take a second to do that. It won't hurt you. We're not going to jump into math right away. Get that in there with a few notifications. That way it doesn't sneak up on you. While we're here, and before we dig into these other things, I just want to remind you guys that we do have some tutors on campus. You can go visit them at the library in person, and they are good there. Sometimes math faculty just roam the learning commons, offering help to people, which is very nice. Dr. Pinot, Dr. P, a very tall, older Frenchman, the bald head, is one who's known to hang out there, and he's a great guy. I encourage you to talk to him. The tutors that work at the Commons are also quite good, especially when it comes to Calc 1 stuff. This is stuff that they can generally handle pretty well. If you want to talk to a tutor online, which is perfectly reasonable, this being a hybrid class, just follow the link there in Canvas. Scroll down until you see Math and Statistics. And then within here, you'll see tutorings for all levels, math, statistics, visit the Learn in Commons Canvas page, click that. If you're not signed into Canvas, it'll ask you to sign in here. And then at this stage, you can click Math, Science, and Business. And it will take you to this page where you can click this. You'll be dumped into a waiting room for the Zoom meeting. They'll ask you what class you're here for, and then they'll pair you up with a tutor. The online tutoring is pretty good. I'll tell you this, my wife took all of the calculus classes here over the last couple of years during the pandemic, and she got a surprising amount of good quality help from the tutors. They're not perfect at everything, but they are students who took those classes recently and got good grades in them. So they can, at the very least, kind of walk you through how to solve the problems. It's not at all a replacement for talking to me or coming to office hours, listening to the lectures, that sort of thing. But if you need a little bit of extra help or you're stuck on a problem, definitely coming to the tutors online or in person is a really good thing to try. What else? That's about it. We're going to talk about all this other stuff in a minute. So let me go ahead and open up the syllabus. Because the next thing I'm going to ask you guys to actually do, go ahead and follow this link on your computer and save a copy of the syllabus somewhere you can get to it. So if you click that link, you'll be prompted with this dialog. Go ahead and hit save. Then pick a spot on your computer where you'll be able to find it. I strongly recommend that you create a folder somewhere on your desktop or something like that, where you save stuff for this class, because there will be other stuff. I'll go ahead and save over this, why not? If you did this earlier, so I think I posted this yesterday or the day before, there was one thing missing from the syllabus there. So even if you saved a copy of this like yesterday, please go ahead and download a fresh copy of it today. There's one thing I updated, and I'll share that with you. Let's do it. And let's do it. Okay, so this is the syllabus for the class, the thing I would normally hand out a paper copy of on the first day. It's got all the basic information you need and answers to many questions you will likely have. Of course, it's Calc 1, semester spring 2022. The section number is 004. That is something you want to remember. My name is John Filesticker. I'm an assistant professor here at Santa Fe College. Been teaching here at Santa Fe for 5 years. Taught at UF for a couple of years before that, taught at UCF for a year before that. So I've been doing this for a little while. Santa Fe is a great place both to work and to learn. So I'm excited that you're all here. I'm certainly happy to be here. This is my email, and you can just click this. It's a mail to link. It'll open your mail client. But the best way to get a hold of me is Canvas messages. All the Canvas messages forward automatically to my email, and they automatically tell me what class you're in, what section you're in, and all of that, which is very nice. If you do want to email me directly, that's fine too. But I'll ask you in the subject line, just say Calc 1 or Mac MAC2311, something like that, so I know which class you're coming from. This phone number is my office phone number. It does forward to my cell, so you can call this and get a hold of me. But I'll tell you, outside of business hours, outside of like 9 to 5, Monday through Friday, I do not answer those forwarded calls, and I don't get caller ID with them because they're forwarded. They just show like they're coming from my office. So phones are not the best way to get a hold of me. Texting at this number won't work. Definitely Canvas messages are the best way to get a hold of me. Class meetings, we already went over: Monday, Wednesday, Friday, 2 to 3:15. Office hours, Monday, Wednesday, Friday, 1 to 2, Tuesday, Thursday, 11 to 12 on Zoom. If you want to make an appointment, we can meet outside of that or in person. Just send me a Canvas message. Final again is 4/26 at 3:30. Stuff you need for the class. You do not need a copy of this textbook, right? You don't need to go buy a hard copy of this if you don't want to. You do need an access code for WebAssign. So WebAssign is one of those online homework portals, kind of like My Math Lab or My Open Math. You have to pay for the access code, which kind of sucks. I think it's around $100 for one semester, maybe a little less. You can pay more to get a multi-term access code. If you know you're going to take Calc 2 after this or something like that, then it might be worthwhile to get one of the multi-term codes. Either way, the other bit of information you need to register for WebAssign is this class key. So I would just copy paste this to make sure it gets over correctly the way you do it. Come here, click this link to go to WebAssign, then click enter class key. You will copy and paste that class key and click enroll. And it'll be like, is this the class? And the answer is yes. And then you would click continue. See if I'm logged in as my instructor account right now. It may, yeah, no, okay. So normally what that would do is ask you to either create an account or sign if you already have one, and then it will ask you for your access code. If you don't have your access code yet, either you're waiting for your financial aid to come out or it hasn't arrived in the mail yet, that's fine. After you enter the class key and tell it that you want to join this class, it'll give you the opportunity to input an access code. If you don't have it yet, just look a little bit lower on that page and there will be a gray link that says use temporary access. That will get you in for 2 weeks. So even if you don't have your access code, you can get in and get started, and you need to do that because we do already have homework here. And we'll talk about the homework schedule in just a minute, but you do already have a homework set. You can get in even if you don't have your access code. The only thing you need to get in is the class key. And you need to do that today. I need everybody to get in and get registered for our class in WebAssign today, because as you see, your first homework set is already here. It's all limit stuff, and we'll talk about the specifics of the math later, but just wanted to show you the homework before I move on. So somewhere around, 50-ish problems. Most of these are very quick, but some of them will take you some time. And it is the case that every week we're going to have a big homework set like this, and you want to stay on top of it. Okay, other stuff you need for the class. You don't need a calculator, but if you want one, this is the only one you can use, the TI-32XS. And I know it's a long, weird name. It's unfortunate that there are other TI-30s that are not okay to use in this class. This is the only one you can use, specifically on tests, right? I can't stop you from using other stuff on the homework. Of course, I would prefer that you not. But on the tests, this is the only calculation device you are allowed to have handy. And the other TI-30s, TI-30 Pro, TI-32 Pro, whatever, those things are not allowed. Definitely no graphing calculators, no calculators that can do symbolic manipulation, just the TI-32XS. Good news, these new are pretty cheap. They're like $12 at Walmart. If you walk around downtown Gainesville on any given day, you can probably find one in a gutter somewhere, because Gainesville, I saw one on the floor of a cell phone store the other day. They're around, all right? If you're having trouble finding one of these, let me know, I can get you one. It's a hybrid class, so you need a computer. You want to keep your web browser up to date. You need consistent internet access. This can be tricky. If you know that your apartment complex or wherever has like spotty internet access, I strongly encourage you to have a backup. Most cell phones these days have hotspots. That's what I use for my backup when my shit goes out. But have something like that planned. If your phone doesn't have the hotspot capability, maybe have like a secondary place in mind you could go, like a coffee shop where you know you can roll up and hop on the internet, something like that. But you really do need consistent internet access, especially for the tests. TI-30X2S. Oh, let's see. Yeah, I think, okay, Cody just pointed something out to me in chat, and I appreciate that. Yeah, I think that the X belongs over here. Yeah, TI30X2S. It's a typo. I'm sorry. So yeah, TI30X2S is correct. That one is the one you want. What else are we going to say? Okay, so for exam proctoring, right? If the internet drops and you get booted out of class for a second, that's not the end of the world. You can come back and I record all the lectures. I post them to YouTube. So if you miss 5 seconds of the lecture while you're trying to get back in, that's not so bad. During a test, that's a problem, right? So that's really why you want that backup internet source. You want something that you know is going to be consistent because you don't want to get kicked out during a test. We proctor the tests using HonorLock and Zoom. So in addition to these things, you need a smartphone. You need a phone that can run Zoom or a secondary device. Doesn't have to be a phone, could be a tablet or something like that, but you need a secondary device with a camera that can run Zoom, because the way the proctoring is going to work, we'll have HonorLock running on your computer that will record your webcam, that will record your screen, and what's going on within the test. And then separately from that, for the test, you're going to need to set up your phone off to the side, somewhere I can see your desk, your hands, your paper, your lap. As we get closer to the tests, I'll talk to you about the proctoring conditions a little bit more, but just be aware, you need 2 devices. And the secondary device needs to be capable of running Zoom. Course description. This is the first course in a 3-course sequence on the fundamentals of calculus. We're going to focus on skill building and problem solving, and the main topics are understanding real numbers. Turns out the number line, real numbers, it's actually a strange place. All right, if you were a tiny little dude living on the number line, you would be like, whoa, this is a weird town. We're going to talk about functions, continuity, rates of change, limits, derivatives, how to differentiate a function, whatever that means, and then a bunch of stuff that you can do with those calculus basics once you understand what they are and how to do them. There's an official list of course objectives. You can follow the link if you want. Here are all of the official topics we're going to cover. But I'll reveal them to you as we go. It's not necessary to memorize that list or anything. Technology policy, just be polite, right? Be polite, don't distract others. Obviously, I'm not so worried about you scrolling snaps to book in the back of the class because this is not a class like that. But I'll ask you to keep the chat in Zoom focused, right? So let's not like DM each other or message things that are irrelevant to class or the lecture in the chat. And then also please don't message people on other platforms, right? I will be making a Discord server for this class, and I want you guys to use that Discord server, but during the lecture itself, let's keep our attention where it should be and not draw other people's attention away. Attendance. One of the nice things about Zoom is that it takes attendance for me automatically. I will take roll every day, not just the first 2 weeks, but I'll be checking it for the first 2 weeks. It'll take roll automatically. Only thing to be mindful of there is that your name in Zoom should be the same name that's on your Santa Fe ID. That way I can line those up. In order for your financial aid to disperse, I need to be marking you as attending. And if your name here is something different than appears on my roster, then it can be a little bit hard to line those up. So let's use in Zoom the name that appears on your Santa Fe ID, not a nickname or something like that. I am pretty lenient about makeups. If you miss a test for whatever reason, I'm not gonna beat you to death over it. I just want you to take the test. Now, I say you need a reasonable documented excuse, and that's true to an extent. You just got to tell me what happened, really, and I'll schedule a makeup for you. We just got to do it within a week. That's the rule, right? So if a week goes by and we have not done the makeup test, then that test is going to be a 0. But if you know you're going to miss a test because you're out of town or something is going on, let me know ahead of time. We can make an arrangement. If you miss a test due to something unforeseen or just absolutely not being ready and you bail because you can't make yourself come, whatever, just let me know and we'll arrange a makeup. Again, I just want you to take the test. I'm not terribly concerned about why you missed it, just want it done. Only catch is we got to do it within 1 week to keep you from falling behind. Homework stuff, if you miss a homework or if you want a homework extended for whatever reason, don't worry about it. You just need to put an extension request in WebAssign and I will grant it. I go through and clear those out once per day. So you'll never have to wait more than 24 hours for the extension to be granted. Just put in the request and I will grant it as soon as I can. Oh, good question, Isabella. Yeah, no makeup for the final. The final is the one exception to that thing. So midterm exams, I'm happy to work with you, but for the final, it's got to be done on that day and that time, unless there's something really extenuating going on. Okay, homework and study guide. So every week I'm going to publish a homework set for you in WebAssign. They're pretty lengthy and expect to spend 3 to 4 hours minimum on those problems. The homework is going to be published after our class meeting on the first class of that week. So for example, your homework set is open now. Normally I would publish it at the end of class on Monday, and it will be due at the start of class on the first day of the following week. So your first homework set is open now, and it will be due at the start of class next Monday. And then that will be our cycle. They open on Monday and they close on Monday at the beginning of class. There are study guides. So about a week before each of the midterm exams, I will post a homework set to WebAssign that has between 10 and 20 special problems I picked out. You will solve those problems and enter your answers in WebAssign just like you normally do. But in addition to that, you need to save your written work for those problems, scan it, and upload it to Canvas. I'm going to talk more about how to scan and upload things in a minute. But the important thing to remember about the study guides is that in order to get the credit for them, and they are worth quite a bit, in order to get the credit for the study guides, I need your written work. It's not about answering the questions in WebAssign, it's about getting me the written work. That written work is not graded for correctness. Every problem could be wrong, and you still get full points on it as long as you attempt each problem. The kind of thinking, the idea behind the study guides is that I get to see how you're solving those problems and give you feedback before the test. So I can say, oh, on the test, this would be a 2-point mistake, or this looks perfect, or, oh, are you using radians or degrees here? Whatever it is, I want to be able to see what you're doing, tell you how I perceive it and how I would grade it on a test. That way, when the test comes around, you won't be surprised by the criterion, the standards, or how I mark things. Study guides are due on the day of the test, but I want you to turn them in as soon as you can, right? So go through the study guide problems, take a crack at each one, scan and submit that work right away. The sooner you get the work to me, the better the odds are that I can give you some written feedback on that work before the day of the test. But the absolute latest, the day that the study guides are due, is the day of the test itself. Lab meetings, we talked about this a minute ago. So Mondays are officially our lab day, but hybrid online class doesn't mean, we're not going to meet in X120 instead of online. We're going to meet online every day. So the lab periods will mostly be problem solving sessions. On those days, I'll try to focus on working examples. And then we will have a few projects where I ask you guys to use Desmos or some other free computer algebra system, just 3 or 4 of them throughout the term. But be mindful of that. There will be some Mondays where I ask you guys to do stuff instead of just coming in and listening and taking notes. Exam structure. So there's 3 midterms and 1 final. The 3 midterms will take place during regular class time. They're going to be on Canvas. They're structured as Canvas quizzes. They will be proctored using Zoom and HonorLock. So Zoom on your phone or tablet or whatever, and then HonorLock on your computer. HonorLock only works in Chrome, so you need to have the Chrome browser installed on your computer, and you need to have a webcam, obviously. You'll need to have your student ID. That's a necessary component for HonorLock as well. That's about it. They're going to take place during normal class times, and the final, again, is going to be Tuesday the 26th at 3:30, and it'll be structured the same way. It'll also be structured as a Canvas quiz and proctored using HonorLock and Zoom. So both the study guides and the tests require you to submit written work. Let me show you in Canvas really quickly. See my face for this. So here are the assignments for the semester, study guide, and then you see below exam 1, this is where you're going to click to take the test. You probably can't see it because it's, I've got the date set in there. And then exam 1 written work. So the study guide and the exam both require you to submit written work. There are several ways you can do that, right? One option would be to somehow get me the physical paper, right? Now for the tests, I need that written work immediately after the test. That's not really an option. So the thing that we actually do, I recommend that Android users download either Adobe Scan or Cam Scanner. These are apps that you can download on your smartphone or tablet that produce good, high quality PDFs of whatever it is you scan. Don't just take a picture using your phone's camera. That shit always comes out terrible. I need good, high contrast, high resolution PDFs in order to get in there and annotate them, which is what you want, right? You don't just want to grade back on your test. You want to see the comments I write, the actual correct solution if there's a mistake, explanations to why you lost points. In order to get that, you need to give me a good, high quality scan of the work. So I recommend on your phone, download one of these apps, either Adobe Scan, which is here, or Cam Scanner, which is here. They're both free. The free version of Cam Scanner, I think, has some limitations, like it's got a certain file size you can do, or maybe just a maximum storage cap, I'm not sure. But both of these are really good. If you have an iPhone, you can also use the Notes app, play around with it. There is a scan function within the Notes app that produces similar quality scans. But all of the things that you have to submit written work for need to be scanned in this way. Don't give me JPEGs or HIC files or bumps or PDF, just the PDF, right? I need a high quality PDF scan. And there are plenty of ways to do that free, easy. But please, no pictures. All right, recording notice, I mentioned this at the start. So this class meets on Zoom. I record the Zoom meetings and I do upload them to YouTube, just to be aware of that. I do like you to have your cameras on. I know I cannot force that, but I really appreciate it. It means a lot to me if I can see your face, because that really helps me see how well you're getting the material, right? If your brows are furrowed, then probably it's not going great and I need to talk a little bit more, show another example. If everybody's nodding and smiling, then I know things are going well. So the more feedback you can give me, the easier it is for me to help you learn. And the best way to give that feedback is just for me to be able to follow your facial expressions. So if you're willing to, please leave your cameras on, at least as much as you can. I understand if you got to turn it off. If you have to walk away, that's okay. That's all right. It's not the end of the world. I'm not going to judge you for that. But as much as you can, leave your cameras on. Just be aware that the meeting's being recorded. There is this little dashboard on the right where your face will show up, and that will be on YouTube. So don't let your roommate take bong rips in the background, that sort of thing, please. Some important dates. These are all things that you should be aware of. Put in your calendar. Obviously, classes start today. The last day to add a class is the 7th. The last day to drop without anything showing up in your transcript and get your money back, that is the 11th. Our first holiday is Dr. King's birthday on the 17th. College is closed for spring break the 2nd week of March. And then March 23rd is the withdrawal deadline for the class. So if the class is just going poorly, the first 2 tests don't come out well for you, and you want to bail, you don't want an A through F letter grade, you would rather take the W, then the last day you can do that is on the 23rd of March. It is possible to withdraw after that date, but you have to file a petition with the petitions committee. It's a little bit complicated. So I strongly encourage everybody to kind of stop and assess where you're at on or before that day. The last day of class is the 22nd of April. The final exam is the 26th of April, and your grades will be posted to eSanta on the 3rd of May. Is there anything else we wanted to say here? Oh yeah, the withdrawal deadline and the course schedule. We'll get to that in a second. Before we get to that, let's talk about grades. So in this class, the vast majority of the grade comes from the exams. Right? Midterm exams are worth 100 points each, or 53% of the grade. The final exam is worth 150 points, which is a full 26% of the grade. So between these two, you see that 79% of the grade comes from proctored tests, which means you really want to prepare for those tests. That is definitely the bulk of the grade. The homework and study guides are also worth something, about 21% of the grade together. Each study guide is worth 25 points, or about a quarter of an exam. The homework altogether is worth 45 points, a little less than half of one exam. When I first started teaching these classes, I didn't grade either of these things. These were optional, do them if you want, and nobody did them, and then everybody failed the tests. So it's important to work these things, but the only reason they have a grade value is to compel you to actually do them. So please spend the time doing the homework and study guides. They're only here to help you. That's the idea, right? I'm sure everybody at some point has tried to build a skill in the past. My wife's really into hula hooping, so that's the analogy I use, right? Like if I pick up a hula hoop and try to do any of the stuff she does with it, it looks ridiculous, and I fall over and I hit the dog with the hoop and everybody's sad. But she practices a lot, so she's really good at it. Math is the same way, or skateboarding, or whatever it is. You want to build a skill, you need to practice. And the homework is where you're going to get most of that practice. It's important that you solve the homework problems honestly. And what I mean by that is not leaning too hard on any outside resources. It's okay to talk to a tutor if you get stuck. It's really good to come to office hours and talk to me if you get stuck. But you want to work those problems until you're to a place where you're getting them right the first time, at least most of the time. Once you get to that place, then you can be pretty confident that you're prepared for the test. But if the homework problems, you find that you need to get help on all of them, or you're looking up answers just to get them into WebAssign and move on, that means that you need more practice. So please practice and be honest with yourself as you practice. You'll know because it will feel good. If it isn't feeling good, then that means we need more work. And there are things I can do to help you enjoy that. There are ways to make it fun. There are lots of good tricks and tips that I'll try to reveal to you as we go through the material, how to kind of enjoy this material. And that's the key, is to find a way to take pleasure in the work. There is work here. There's no getting around that. But if you're able to enjoy it, then you'll find yourself putting in more than you need to put in, and you'll destroy this shit. You'll come out with a solid A and everything's going to be great. If you don't put in the work, then the exams are going to be an unpleasant experience. And because they are pretty much all of the grade, it is nearly impossible to pass this class without mastering the material. That is the goal. Grading scale is the normal one. 90 to 100 is an A, goes down by 10 points after that. The top 3 points in each category earn the plus designation. And because I know people are going to ask towards the end of the semester, the way I do things at the end of the term, if you're within 1.5 percentage points of the next letter grade, I'll round up. So an 88.6, that's an A. The next page in the syllabus, this is all just stuff the college requires me to put in here. The jellos, there's going to be one assignment. We used to do this through the final exam. I think it still says final exam. This is the official thing. There's going to be an assignment that I give you at one point in the term that is called a jello assignment. It's just a worksheet. And this is something that the college requires us to do to kind of see how well you've mastered the material of the class. It's not going to have a big impact on the grade. It's going to be a very small impact on the grade. But it is important for statistics purposes, just to see how I'm doing. It doesn't go on your transcript, nothing like that. Academic integrity, we're going to talk more about this later, just don't cheat. ADA, if you have any sort of disability, learning disability or otherwise, I strongly encourage you to talk to the DRC. Even if you've never been diagnosed, you're just curious, you think you might have ADD or something like that, talk to the DRC. They're very nice, they're very helpful. And if you have talked to them or are planning to talk to them, let me know. We can have that conversation in private. You can do it with email, whatever. I want to make sure you get whatever sort of testing accommodations you're entitled to, whether that's extra time or a quiet environment or a note taker, anything like that. Happy to work with you. Just let me know, and also talk to the DRC. That way it's official and I can explain why we're doing what we're doing if I'm ever asked by the college. Similarly, accessibility stuff, this is tricky with math, but all of the materials I publish, including the syllabus, are written in the markup language LaTeX, which means they work well with screen readers, anything like that. So if you have trouble with vision or anything that makes it difficult to read text or to parse text, just let me know. There are screen readers available through the college, and I do my best to make sure all the materials are compatible with those. The YouTube videos will be annotated. They'll have we call them subtitles, closed captions. So if you have difficulty hearing, that is a good option. If there's anything like that, accessibility-wise, that you need help with, just let me know. Discrimination and harassment. This could just say, don't be an asshole. Pretty please, be nice to everybody. Student rights and responsibilities. I recommend you take a look at this. Kind of like before you get your driver's license, you have to know what the laws are. It's only taking that part. Looks like this link is broken for some reason. These are the rules that the college judges you by. Oh, no, it's not that. All right. All right. So, this is the stuff the college expects of you. There's an awful lot of it, right? And so not everybody needs to worry about animals on campus, but I suggest you scroll through here, take a look at this. It helps to know, right? It helps to know what your rights are if you feel like something has been done that is inappropriate. Again, I'll use my wife as an example. We did have a professor who was very inappropriate with her, and we had to go through this formal complaint process, and they were able to make things right. So it's important that you're aware of your rights. It's also important you're aware of your responsibilities. There's a lot of help out here for you. And then there's also some rules that you're expected to follow. So please be mindful of those. Counseling services at Santa Fe are very good. If you're feeling overwhelmed, then you're right, you don't need to be depressed or suicidal, but certainly if you are feeling that way, but if you're also just feeling tired or overwhelmed or sad, talk to the counselors. They're great. They're very, very helpful. We do require that you have a computer for this class. If you have problems with your computer, if it's not able to do the things you need it to do, or it's just not working, whatever, check out the laptop loan program. This is really solid. They lend out some nice laptops. All you got to do is give them this basic information. They've got a pile of them there, and they're happy to give you one to use for the semester. I'm not going to go through the rest of this, but I encourage you to, right? I encourage you to take a look because those are the things that the college expects you to do and will do for you. The last part here, this is related to the academic integrity thing above. Ever since like late March, early April of 2020, the college has been pushing as many classes as it can online. Testing, especially testing mathematics online, is a challenge for a number of reasons, but the most obvious one is cheating. Let me start here. I also have this, right? We all have a smartphone. I have a smartphone, you have a smartphone. I have Photomath, I have Mathway, I have Symbolab, I have Wolfram, I have a Chegg account. I keep track of what's going on. I use Bartleby. I know what a good solution written by someone who knows what they're doing looks like. I know what an okay solution written by someone who kind of knows what they're doing looks like. And I know what a solution prepared by an artificial intelligence on Photomath or Mathway looks like. And I cannot tell you how many times I've caught people cheating, just copying shit out of Mathway and putting it down on my test and thinking that because they've got their phone out of view of the camera, I'm not going to know. Trust me, I know, right? It's just one of those things. This is what I do for a living full time. It's not hard to tell. Don't cheat. If you cheat, I will catch you. I have one person here who took, two people here who took pre-calculus with me last semester. And I'll tell you, in that particular pre-calculus class, I caught 6 people cheating on the final, 4 people cheating on the last midterm. It didn't work out well for any of them. Don't do it. And none of that, by the way, none of that was like something super obvious on the video. It was all stuff that I picked out by looking at their work. And then the video reinforces it. So please don't cheat. Please don't cheat. I promise you, no matter how clever you are, it will show up. Okay. I will do my best to be gentle the first time. So my rule on this is if I catch you cheating once, I give you a 0 on that assignment. I don't care if it's the final or a midterm, whatever it is, 0 on that assignment, stern warning. If I catch it a second time, then I'm going to file a complaint with Dan Rodkin's office, and I'm going to give you a ZF in the class. A ZF is more stern than a regular F. It's not just you failed the class. It's you failed the class for academic dishonesty. And that is really bad if you're trying to transfer somewhere. It doesn't look good if you're using your transcript to try and apply for an internship. Trust me, you don't want it, right? You really don't want it. And in extreme circumstances, I had a student bribe me once, or attempt to bribe me. And he did it to his physics professor at the same time too. So, Rodkin expelled him and he actually lost his visa. That was a sad instance. So please, 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 just be honest, be real. That's the stick, right? You hear about the carrot and the stick. That's the stick. Here's the carrot. If we're getting close to an exam and you feel like you're not ready, you're feeling that like nervous, my back is against the wall, and you start looking around wondering where you can tape a cheat sheet or how you can use Photomath during the test on your phone, some bullshit like that. Can you borrow a second phone to hold in your lap during the test? Don't do that. As soon as you notice your brain click over into that mode where instead of preparing for the test, you're preparing to cheat on the test, recognize it and send me an email. Send me an email. It doesn't have to say anything incriminating. You can just say, I'm not ready, I'm stressed, whatever. I will work with you, right? I'm willing to postpone the test up to a week for you. And during that week, I'm willing to have one-on-one office hours with you. We can arrange tutoring, anything you want. Please don't cheat. If you feel yourself stressed out in that way that makes your brain start going to that place, reach out to me instead. I promise you I will work with you. Even beyond the 1-week extension, there are other things we can do, like incomplete grades. I would much rather do that than have to go through a conduct trial. All of our brains do that sometimes, right? When we're feeling really stressed and really pressured, we start looking for alternate ways to cut corners or something like that. I acknowledge it. It's a very real thing. It's not anything you should be ashamed about. If your brain does that, it's okay. But instead of following that path, stay on the good path. Talk to me. I swear I will help you. I promise I won't judge you. But please, please don't cheat. I catch people doing it every semester. It's never as sneaky as you think. All right, that's that stuff. Sorry about the soapbox thing. Here's the course calendar. This is about what we're going to do this week. We're going to review algebra a little bit, and we're going to talk about tangents and velocities, limits of functions, that sort of stuff. Next week, we're going to address limits in more detail. We will talk formally about what it means for a function to be continuous. This is a thing that we almost certainly have some intuitive notion for, but we will have very specific notation and language associated with it. Talk about limits at infinity, and that's going to get us ready to talk about derivatives. Once we get through all of the derivative stuff, we're going to take our first test. So that first test is going to be end of January, probably the start of February, end of the first week of February. And that's the date I have in there in Canvas right now. After that, we're going to talk about applications of the derivative. So stuff you can do with that first calculus operation. Turns out there's a lot of it. There's a lot of cool stuff you can do with the derivative. So for a few weeks, we will talk about applications of the derivative. And then just before spring break, we will have our second test. Spring break is the second week of March. After that, we're going to come back and start talking about the other side of the calculus coin. Turns out calculus is really about two operations. One is called the derivative. The other is called the integral. And they do different things, but are related to each other through some really cool operations. So after spring break, we're going to come back and instead of talking about the derivative, start talking about the integral and how to find areas using calculus. We will connect the integral to the derivative through the fundamental theorem of calculus. We'll talk about some applications, and then we're going to spend the last few weeks kind of priming you for Calc 2, which is learning about U sub, finding areas between two curves. And there will be a few other topics that I throw in here if we have time for them, fun things. But that's it. And then the final is on the 26th of April. Just a quick note, all the dates here are rough, quite rough. It's not uncommon that we shift things around or delay a topic or spend a little bit more time on one topic if it seems like that would help you guys. So these dates are useful, but they are far from concrete. The dates that I put in Canvas for the exams are just the last day of the week that we're supposed to get to that exam. So those will change almost certainly. But just to give you a rough idea of when we're going to cover what topic, that is what this is for. All right, that's me rambling for a long time. Do you guys have any questions from the syllabus stuff, the structure of the course, where your grade comes from, what's expected of you or what you need, anything like that? Okay. Then we're going to come back over here and we're going to begin talking a little bit about mathematics. I guess before we get to the tangent lines, velocity stuff, I want to talk just a little bit about the real numbers. So I would like you to think of the real numbers as a place, right? It is a set of mathematical objects. Each one of those objects is called a real number, and they can be arranged on a line. The symbol for referring to the real numbers as a whole thing all at once is this Blackboard bold R. It's an R with an extra leg on the side. These form the real numbers. I should say the unique. And now I'm going to give you 3 words. Each one has a very specific meaning. And if you've taken other classes with me, you may have heard this before. They form the unique, complete ordered field. So if you are an algebraist, someone who studies the structure of different mathematical objects, the real numbers can be completely determined by saying they are complete, they are ordered, and they are a field. Complete means there's no gaps. Right? In other words, between any 2 real numbers, there's infinitely many more real numbers. No matter how tight you zoom in on that number line, you'll never find even a tiny, tiny gap. So between 0 and 1, it's not the case that there aren't any numbers. 1/2, 0.3, 1 over pi, all of those exist between 0 and 1. So do infinitely many other numbers. And it's so tightly packed in that there are no gaps, no matter how tight you zoom in. All right? If I zoom in on this water bottle, I've got my background thing on. If I zoom in on this water bottle, you would find gaps. It's mostly empty space, right? When you get down to the atomic level, protons, neutrons, electrons, most of that shit is space. The nucleus of an atom is packed in pretty tight, but there are massive gaps between the nucleus and the electrons which orbit. That's not the case with the real numbers. No matter how you zoom in, no matter how finely you look, there are no gaps. It is a solid line. Ordered. This means if you have two different real numbers, one is always bigger than the other. Right? So if you have two distinct real numbers, one of them is larger. Either y is bigger than x, and that's said like this, right? This says x is less than y, or y is less than x. If you have two distinct real numbers, not the same number, then one of these must be true. So the real numbers can be arranged on a line. That's another way to say this, right? Ordered means that as you go to the left, they get bigger. As you go to the right, they get bigger. As you go to the left, they get smaller. One is always bigger than the other, or they are equal. If they're not equal, one must be bigger than the other. Field, this is the big one. This means we can add, subtract, multiply, and divide any two numbers. As long as we don't divide by 0. Right? So a field is just the name for a mathematical structure where those two operations can be performed. The real numbers are not the only place you can do this, by the way. If you have complex numbers, right, like numbers that involve I, you can add, subtract, multiply, and divide any two of those. Those are also a field. They are also complete, but they're not ordered. So the real numbers are the unique, complete ordered field. There are other fields, like if you look at the remainders of all the integers, modulo, some prime, other stuff like that. There are many, many different fields, but the real numbers are the only land in the universe of mathematics where you have a complete ordered field. We will be working almost exclusively with real numbers in this class. From time to time, I may reference complex numbers, but we're working almost always with real numbers. And the way you should visualize them is as living on a line, right? You can put 0 wherever you want. And the idea is no matter how tightly you zoom in, there are no gaps. So things like this, right? These are all real numbers. Negative square root of 2, 1 over pi, 1, of course, e. And they live on a line. They get bigger as you go to the right. They get smaller as you go to the left. Interval notation, I'm not going to review. Hopefully you remember interval notation from your pre-calculus class. It would take too long. And if you don't remember that, then we're in trouble anyway. So the real numbers are the land where we live, where we work, and we want to try to get to know this land. It might seem like a simple place, but it really isn't. This whole complete thing turns out to be very strange in a lot of ways. Most number systems are not complete. For example, the integers, the whole numbers, not complete. There's a big gap between 0 and 1. Even the set of all fractions made up of integers like 3/5 and 1/17, if you look at all of those together, they are an ordered field, but they're not complete. So this completeness criterion, this is a big deal, and it turns out to be really important for all of the calculus operations. Open intervals will be of importance to us because they are the nice way to express statements about completeness. So what do we try to do in calculus? Specifically, this first part of Calc 1, we're trying to figure out the slope of a tangent line. And that doesn't mean much to us right now. So let me talk for a second about slopes and rates of change. So if you have some function, function f, we can discuss the graph. graph of a function is a collection of ordered pairs, x comma y, where y is always equal to the output from that function at that x value. So if this is my x-axis, this is my y-axis, the graph of a function should be a curve, something like this. And if this is the x value a, then the point on that graph is the ordered pair a comma f of a. So the y coordinate is always f of the x coordinate. And that's why you see this written over here so often, y equals f of x. Well, this is an ordered pair. It's an x comma y. And the thing that is the y is f of the thing that is the x. If I have another point on the graph over here, say at b, then that would be b comma f of b. And given 2 points in the plane, we can always talk about the line that connects them. So let's take a look at that line. All right, this dotted blue line here is called a secant line. And the word secant is connected to the secant function. You remember from trigonometry, the 1 over cosine or secant function. Turns out that secant function can be thought of as a secant line on the unit circle, right? The length of a secant line is related to the secant of the angle that gets you to that point on the unit circle. But more generally, if I have any graph in the plane, I can take 2 points on that graph and connect them with a line. That line is called a secant line. The slope of that secant line well, you take the rise over the run. So the rise is the difference in y values. That's f of b minus f of a, right? y2 minus y1 divided by the run, which is b minus a. And of course, this is function notation, right? F of b, it's not f times b. This is the y value or the output associated with b. This is the y value or output associated with a. So it's your normal slope formula. It's the formula you've used for slope since middle school. Eventually, what we want to do is to bring this point closer and closer and closer and closer over to this point. And that will get us something called a tangent line. In order to understand the value of that tangent line in terms of real world stuff, I'd like to pretend that this function is measuring something. So what would be a good thing to measure? How about, so let's say, suppose that f of x measures, let's say how tall the grass is, or let's make it one thing in particular, how tall a tree is, x years after it is planted. Right, so maybe when I plant the tree, it's 2 feet tall. That would mean f of 0 is equal to 2 feet. Right? 0 years have passed since I planted the tree, the moment I plant the tree. And when I plant it, it's a little seedling. It's just 2 feet tall. Maybe f of 1 year later, maybe the thing is 6 feet tall. Maybe f of 2 is 8 feet tall, and so on. If I want to calculate one of these slopes from the picture above for this function, the slope of the secant line from x equals 0 to x equals, say, 2 is f of 2 minus f of 0 over 2 minus 0, just following this formula. Now f of 2, that's 8 feet. So this is 8 feet minus f of 0 is 2 feet. And then downstairs, I have 2 minus 0. Now these are measured in years, right? This is 2 years and this is 0 years. So down here I have 2 years. If you subtract 2 feet from 8 feet, you get 6 feet. And downstairs, I still have 2 years. And here's the neat thing. This is called dimensional analysis. You can take the units off to the side and do algebra with them. So 6 over 2, that's 3. And this is feet over years. And feet over years is a unit that describes a rate of change. We would say that over the first 2 years, my tree is growing at about 3 feet per year. And the specific kind of rate of change we're discussing here is an average rate of change. I guess it should be an and if we're to say average, but you get the idea. So on average, over the first 2 years, that tree grew 3 feet per year. Now that doesn't mean it was growing at that speed all the time, right? If you look from year 0 to year 1, the thing grew 4 feet. It went from 2 feet tall to 6 feet tall. So it was growing faster at first. And then from year 1 to year 2, it went from 6 feet to 8 feet. That's 2 feet. So it started growing faster and then it slowed down a little bit. The big thing we want to do in this first part of Calc 1 is figure out how fast that tree is growing at any moment in time. Like if I look out my window right now, the tree is growing. At this exact moment in time, how fast is it growing? That's the big question we want to ask. And it can be related to the geometry of this picture. So the slope of the secant line, which is this expression, describes the average rate of change. If I bring this point closer and closer to this point, then this secant line will, well, those points are closer together, it'll approach something called a tangent line. So what we would like to do in this class, first, we want to be comfy with thinking about ratios with units like this as rates of change. And hopefully that's something you've seen in your algebra classes. But what we really want to do in this class we want to answer the question, how fast is the tree growing right now? So imagine instead of just having those few values, f of 0, f of 1, f of 2, I have the whole graph. Here's 1, here's 2. F of 0 was 2 feet, so I'll just mark this 2, 3, 4, 5, 6, 7, 8. On the curve here, this is still y equals f of x. F is that same function we were discussing a second ago. F of 0 we said is 2. F of 1 we said was 6. And F of 2 we said is 8. Now with just these isolated points, there's not much that we can do. But if you know the curve everywhere, then you can start to be a little bit more analytic about it. So this is years, and this is height in feet. And the thing that we calculated a second ago was the average rate of change, or the slope of the secant line, from x equals 0, which is here, to x equals 2, which is here. I'll just draw that in. All right, we calculated the slope of this secant line. It was 3 feet per year. So if I asked you, how fast is the tree growing right here, exactly 1 year after I plant it, this would be a reasonable guess, right? This 3 feet per year, because we know from year 0 to year 2, the thing on average grew 3 feet per year. That's what that means. But what I really want is this thing, which I'll just draw it in solid here in pencil. So if I want to answer how fast is the tree growing right now, if right now is when the tree is exactly 1 year old, this would be the slope of the tangent line. And the thing I've drawn in here, this guy, is called the tangent line. And again, from your trigonometry class, you might be familiar with the concept of a tangent line. It's a line that just kisses the graph just right. On the unit circle, it's perpendicular to the radius. You can think of it like if someone was skiing or skateboarding along the graph, the tangent line is the slope of the skis or the skateboard, right? That's the idea. So finding the slope of that tangent line requires calculus, right? The idea is we would take both of these points and slowly move them closer and closer to this point. And once they overlap, that blue secant line would become the tangent line. This is called an instantaneous rate of change. I'm going to misspell this. Instantaneous rate of change. Another good example of this is your car, right? If you drive 100 miles in 2 hours, then you averaged 50 miles per hour. That doesn't mean you went 50 miles per hour the whole time. Everybody knows that their speedometer goes up and down as they press the gas or not. Your average rate of change is how far you went divided by how long it took you to do that. Your instantaneous rate of change is what your speedometer says at any moment along that trip. So what we want to do is learn how to use calculus to go from this average rate of change, which is just a slope, it's a regular old slope that you learned how to calculate way back in 8th grade, to this instantaneous rate of change, which is also a slope. It's just a little harder to calculate. So we want to go from the secant line, the blue line here, to the tangent line, the pencil line here. That's our goal. And the way we do it is by using something called a limit. One can pass from slopes of secant lines to slopes of tangent lines using what are called limits. So the first thing we're going to study carefully in this class is this concept of a limit. And we're not going to start by studying limits of slopes. We're going to start by studying limits of functions. And then we'll build up to studying limits of slopes, because it turns out limits, they're a little tricky. You may know that Isaac Newton is credited with discovering calculus. I wouldn't say inventing, some people might, but discovering calculus, coming up with calculus, whatever. This business of calculating velocities or instantaneous rates of change was a big question for a long time before then. If you're trying to build a flying machine or you're trying to get a cannon to hit a certain place on the hill, all of those things require these calculations. And so for a long time, even before Newton, people worked out ways to approximate these things. And some people, in certain special cases, found out exactly how to find them. But we weren't able to rigorously calculate them. We weren't able to calculate them in a way that we could be 100% confident in the result until Newton came up with this idea of a limit. So a limit is a mathematical formalism for describing what a function does as its input gets closer and closer and closer to a specified value. Right? That's the intuitive idea of a limit. Now, the formal way to describe a limit is the notation for it is called epsilonic notation, and it's a little bit complicated. So it's all in terms of inequalities, and the inequalities are described in terms of quantifiers or arbitrary numbers. You'd say, for every epsilon greater than 0, there exists a delta greater than 0, such that certain inequalities are true. That formalism gets in the way of developing an intuition about limits. So I'm not going to introduce these with the formal definition. I'm going to introduce them with a kind of intuitive definition and a lot of pictures. I will discuss the formal definition with you, but not today. All right, so today we're just going to focus on the intuitive definition of a limit and how you can get limits from graphs. The big idea here I don't care what happens at the specified value. I care what happens as we get closer to it, or as we approach the specified value. Right? Limits do not care what the function outputs at that x value. They care about the pattern or the behavior of the function near that value. So I'm going to draw some pictures here, and we're going to come up with a way of describing limits that you'll be able to use to calculate limits from graphs. That's our goal here today. Any questions on sort of the language or descriptions, the pictures, anything like that? Anything you'd like to ask from pre-calculus that feels a little loose?
Can you hear me?
Yeah, I got you, Eric. What's up?
Do those have any relation to like the trigonometry version of like tangent, secant, and all that?
They absolutely do. In fact, one of my favorite pictures here, let me see. Here we go. This is the one. Yeah, check this out. So some of these are old school things that we don't use anymore. But if you look here at this brown line segment, so we rotate, here's your unit circle, right? The black is your unit circle. You rotate up by theta, and that will get you to a point on the unit circle, right? I start here along the positive x-axis, I rotate up by theta radians, and that puts me at a point on my unit circle. That's this point right here. We know that the y value at that point is sine. We know that the x value at that point is cosine. If you draw the tangent line, the line that just kisses the unit circle just right at that point, the length of that segment from that point on the unit circle down to the x-axis, the length of that tangent line is the tangent of theta. So that's the connection between the word tangent as we're using it here in calculus and the word tangent as it's used in trigonometry. Secant is similar. Here, if we look at the line connecting the origin to the place where the tangent line intersects the x-axis, that's 2 points on a curve. So the line connecting that is the secant line. There are other ways to define these. Let me see if I can find one that gives the secant as a secant in the way we think of it. Sort of. So here they're saying the segment BD is also the secant, and you can think of that as a line connecting 2 points. But yeah, absolutely, especially in the case of tangent. And there are other pictures that do this, I think, a little bit better. Here we go. Here we go. So you can see the tangent as the actual length of the tangent line. And then secant, where is secant hiding here? Same thing here. All right, I'll look for the other one that gives the secant as an actual secant line. But yes, they are connected. Any other questions you guys would like to ask about the terminology or the pictures? Okay, so again, our goal is given a function that measures something to go from a secant line, which tells us an average rate of change, to a tangent line, which tells us an instantaneous rate of change. And the tool that we need in order to do that is a limit. So before we come back and approach tangent lines by limiting secant lines, I just want to talk about how to take the limit of a function. I'm going to introduce some very important notation here. So make sure you write this down exactly as I write it. So this is the intuitive definition of a limit. We say that the limit as x approaches a, that's what this notation means, lim x to a, of the function f of x is equal to some number, I'll call it L, provided as x gets closer and closer to a, the outputs f of x get closer and closer to L. Another way this can be said is that you can make f of x arbitrarily close to L by taking x sufficiently close to A. So let me give you a picture to go along with this. You want these words, this mathematical notation here and also this picture to be exactly the same as I'm drawing them. Okay, and then maybe I'll put a filled in point down here. All right. Now there are some limitations to how good of a picture I can provide to you because unfortunately my pen is only so fine. We know that points are infinitely small, right? And this is clearly not infinitely small. But here's the idea. If I'm walking along this graph, paying attention to my x-coordinate and my y-coordinate, as my x-coordinate gets closer and closer to A from the left, is my y-coordinate getting closer and closer to L. So if I'm a tiny little ant crawling around on this graph, standing to the left of x equals A, standing to the left of here, and I slowly start walking along that graph towards x equals A, are my y values getting closer and closer to L? Well, yeah, they are, right? As I walk along this graph, my y value is going to get very, very close to the y value of this blue line, which is L. And similarly, if I were another ant coming in from this way, and my x-coordinate is getting closer and closer to A, is my y-coordinate getting closer and closer to L? Yes, yes it is. If I call the y value down here, I don't know what, let's call it 1. Then you should remember from your pre-calculus classes that f of A is the y value of this filled in point, just 1. But the limit of the function as x approaches A, lim x to A of f of x would be equal to L. And this is what I mean by saying I don't care what happens at that point, I care about what happens nearby, right? Nearby x equals A, not exactly at x equals A, but nearby x equals A, the y values are getting closer and closer to the y value of this whole, whether you're coming in from the left or from the right. And that is why we are able to say that this is a true statement. Whatever the number L is, it doesn't matter. This might be 3 or something. If the graph is getting closer and closer and closer to that y value as you get closer and closer and closer to A, then the limit is equal to that y value. And the fact that this filled in point down here is something else is emphasizing what I said earlier. I do not care what happens exactly at A, f of A is 1. But the limit as x approaches A of f of x is L. Because as we walk along this graph, getting closer and closer and closer to that point, getting closer and closer and closer to having x value A, my y values are getting closer and closer and closer to L. That's the big idea. This idea of coming in from the left and coming in from the right leads us to a slightly more formal definition. Still not fully formal, but more formally, we say that the limit as x approaches A of f of x is equal to L, provided I just want to describe this walking in from the left and walking in from the right in notation, in mathematical notation, provided the limit as x approaches a minus, and this minus means from the left, and the limit as x approaches a from the right, this plus means from the right, is also equal to L. In fact, this is what when we ask, does a limit of a function at a certain x value exist, we're asking, are these left and right limits equal to each other? And I will annotate here. So this means limit as x approaches a from the left. So this guy, as this guy's x value gets closer and closer and closer to a, that one-sided limit, the limit as x approaches a from the left, would be whatever his y values are getting closer and closer to. And this notation is the limit as x approaches a from the right. Okay, so the overall limit, the limit as x approaches a of f of x, exists if both of the one-sided limits are equal to each other, right? And then that shared value would be the value of the overall limit. I'll give just a second to get this all down. Okay. Well, I think we're just about out of time. Let me do one example and then I'll let you go. It's 2 to 3:15. We've gone a little bit over. I appreciate you guys hanging around. So those of you who want to can begin on the homework. Here's an example. Like this. Okay. So let me call this down here. Let's call this 3, call this 4, and we'll call this y value up here 6. So what I've done here is I've graphed for you a function. Maybe it's a piecewise function or some other weirdly defined function. And I want to discuss one-sided limits at the values 1, 2, and 3. And at the x values 1, 2, and 3. So we've got these 6 things I want to calculate, and from each pair of them, I'll be able to say whether the overall limit at that x value, 1, 2, or 3, exists or not. And if it does exist, I'll be able to say what that limit is. So imagine you're a little dude walking along the graph with your x value getting closer and closer to 1 from the left. So I'm this guy, I'm walking along the graph, I'm letting my x value get closer and closer to 1 from the left. What y value am I getting closer and closer to as I do that?
3.
Yeah, right? As I'm walking along here, my height is like a little bigger than 3, a little less bigger than 3, really, really, really close to 3. And as I get really close to 1 here, my x value is really close to 3, maybe just a tiny bit above. So we'd say the limit as x approaches 1 from the left of this function, f of x, is 3. Similarly, if I'm standing on this graph with my y value just a little bit bigger than 1, walking in from the right, then what are my y values doing there? If I'm over here and I'm walking closer and closer to having x value 1, what are my y values getting closer and closer to?
6.
6, good. So here we would say that the limit, the overall limit, the limit without any plus or minuses, as x goes to 1 of f of x does not exist, because the left and right limits are not equal to each other. Right? The left limit was 3, the right limit was 6. It's worth noting also, what is f of 1? Which one of these 2 points tells me the value of the function at 1?
6.
because it's a solid dot.
Very good. Yeah, exactly. The filled in point tells me the value of the function there. That's the actual point on the graph. There is no point on the graph here. All right, let's try the same thing at 2. If imagine this guy turns around and starts walking towards 2, coming in from the left. What are his y values getting closer and closer to? Remember, you can hold the space bar to top.
4.
4, very good, right? If I'm walking towards 2 from the left along this graph, my y values are getting closer and closer to 4. What if I walk in from the right? What if I'm over here getting closer and closer to 2?
3.
3, good. And again, these are different values, right? So the limit as x approaches 2 of f of x does not exist. And we usually abbreviate that as DNE. And then finally at 3, what happens at 3? If I'm walking along this graph with my x value getting closer and closer to 3, what is my y value doing?
Four.
Yeah, if I'm walking in from the left, my x value getting closer and closer to 3, my y value is getting closer and closer to 4. And from the right, the same thing is true, yeah? If I'm walking in over here, getting closer and closer to 3, from the right, my y value is getting closer and closer to 4. So the limit as x approaches 3 of f of x is 4. This is the logic you need to calculate all of the limits in your first homework set. I'll tell you 1 or 2 quick things. If I were to delete this filled in point right here, if I were to make this an open circle, like a missing thing, a hole, everything we've said here so far is still true. I don't care what happens at the point. I only care about the pattern as we get closer and closer. So if this were an open hole, this bottom line would all still be true, right? Other little things to say, f of 2, similar to how f of 1 was 6, f of 2 is 4. It's the y value of that filled in point. F of 3 is also 4. All right, I'm going to leave it here. This is enough for you guys to start playing around in the homework set. I would like you to do that, please. Between now and Friday, I'm going to ask you to do this. Register and WebAssign. Remember, you don't need the access code. If you've got your access code already, that's great, put it in. If you don't have your access code, just use the class key. And when it asks you for the access code, say, I'm going to use the temporary access. That will get you in for 2 weeks. Go ahead and do that and play around with at least the first few homework problems in that homework set. It's a large homework set. You want to get started on it right away, and it will be so helpful to our lecture on Friday if you do that. Friday, we're going to talk more about limits. I'll show you other ways this can go wrong. Kind of some pretty funny things can happen when you start looking very closely at graphs of functions that oscillate a lot or have lots of jumps or holes. So we're going to look at lots of examples like that, and we will learn how to calculate limits more rigorously. I'll also show you the formal definition of a limit, and we will get ready to start learning some algebra tricks to calculate limits rather than working from the graphs. But most of the time in this homework set, you're going to be working from the graph. So go ahead and get started on that. See if you can reproduce this way of thinking there. If you get stuck with anything, I have an office hour tomorrow from 11 to 12. It's a great time to talk about those homework problems before our next class. And otherwise, I will see you guys on Friday. Is there anything you'd like to ask or talk about before I end the meeting? Oh, I see there's something in the chat here. No, so there's a good question there in the chat. Is it the case that anytime we have an open circle, the limit is dne? No, so if I were to do something like this, if this is 5 and this is 2, then here the limit as x approaches 5, let me call this function g of x. The limit as x approaches 5 of g of x would still be 2. And in this case, g of 5 is undefined. And it turns out this picture is actually going to be very important for the limit that defines the derivative that gives us the slope of the tangent line. So as I approach from the left, if I'm walking along this graph from the left, getting closer and closer to 5, my y values are getting closer and closer to 2. As I walk in from the right, my y values are getting closer and closer to 2. So this limit would exist and would still be 2, even though there is no y value anywhere on the graph above x equals 5. So here g of 5 would be undefined, but that limit still very much exists. And that's that big idea, that weird idea that I don't care what happens at the point, I care about what happens nearby. But we'll get more quantitative about this next time. For now, play around with the graphs a little bit. If you get stuck, that's okay. You can send me a Canvas message. You can ask questions in WebAssign. I'm a little slower getting to those than I am getting to Canvas messages. Or of course, you can come by my office hour tomorrow from 11 to 12. All righty, I got another thing I got to get to, so I'm going to leave it here for today, guys. It's been a pleasure meeting all of you. I look forward to seeing all of you on Friday. If you want to talk before then, you know how to do it. So take care. Bye.